Number 4. Here's what I was going after. If you can calculate this, I apologize, number 5. Had a lot of letters, had a lot of pieces. That probably really made you throw up. But my hope was that you would see hey, wait a minute, I already did all this work up here. So my hope was it didn't turn out to be that long of a problem, because you already did a lot of the grunt work up here in number 4. Okay? Here's the point of number 5. This has the same vertical motion as you walking. The only difference is you're combining that with horizontal motion. Because what you saw was this. Because it was moving horizontally and vertically simultaneously. But to me, it just looked like this. You okay with that? So if you can do this, you should be able to do this. No difference. Other than the fact that it's moving horizontally. Good with that? Okay. Number 6, kind of threw you in the deep end. And we'll talk about that today. Okay, so if number 6 felt uncomfortable, yeah. But I tried to lead you in baby steps. All right, so let's dive in. We have a test on Friday. Not tomorrow. But a week from Friday. Okay? I'm really not teaching you anything beyond this. There's a couple things, but the meat and potatoes of this unit, I'm giving it to you already. You have been exposed. We're just going to get you better. Okay? There are a couple little details, but they're tied into what you've learned already. Okay? So, here we go. By the end of this lesson, you'll be able to calculate position, displacement, velocity, horizontal direction, and projectile. All right, so I have initial velocity of 5 meters per second at 37 degrees. Okay. It's at an angle, so I can break it up into components. Let me just throw out this general statement. 99% of the time, it would be beneficial if you're ever given a vector at an angle to break it up into components. Okay? Sometimes not, but most often it's beneficial. Okay? So, horizontal component. To find the green side, tell your neighbor which trig function you're going to use. Find this green side here. There we go to cosine. Is that the adjacent? Here's the hypotenuse. So, I find that to be equal to 4. Okay? Tell your neighbor what 4 is. Is that 4 meters? Is that 4 meters per second? Is that 4 meters per second squared? Is that 4 kilograms? Like, what is 4? Oh, your name. What is 4? 4 what? For whatever the unit is here, that has to be the unit here. Has to be. 4 meters per second. What is this? Velocity. In which direction? Okay? As this ball flies, five meters a second, 37 degrees. What happens to that 4 meters a second as time goes on? Tell your neighbor and tell them why. What happens to the 4 meters per second? Tell them why.
Because it's not being affected by any outside force.
Or is constant. There's no more force in cancel. You do other classes, in physics classes. And I know. What up? I know. Here's what? I know. Yeah, see, I already know what
Okay. It remains constant because there's no horizontal forces acting on it. Okay, so it's doing exactly what inertia wants to do. Yes? Okay. In the vertical direction. That component. Same as that component. Using 5 and 37, how would I find the blue side? Using 5 and 37, how would I find the blue side? Tell your neighbor, tell them what that communicates, and what happens to that as time goes on. Pretend you didn't know it's a 3, 4, 5 triangle. So you find that to be equal to 3 meters per second. Okay, what is that? How fast ball is moving vertically right at the beginning. Does beginning have 2 ends? Beginning. Okay. What happens to that as time goes on? Slows down. Until highest point. Then speeds up. Going down. Good? I need you to comprehend what it is that you're calculating. Do not just get lost in the math. Sweet, I know how to do this. Sine, cosine, boom, 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 boom. Like, understand what it is, what numbers it represents something in life. That's the beautiful thing about physics is you can take a step back and you're like, what exactly are we doing? Okay, you're applying math. Good? All right. Here we go. Give that one a shot. Here.
We were not 15, they just had to. It did not count last year, it was 15 last year.
I didn't know where any of it is.
Some of us are too.
Okay. Thumbs up when you know the answer. Thumbs up when you know the answer. Have a conversation. Oh, sorry, let me, overall, what I mean by that is resultant. Like a combination of your X and your Y, horizontal and vertical, overall. Have a conversation.
I love using it. And that's just much
Correct answer is? B. Okay. Horizontally, it's moving at a certain speed, and it remains moving that same speed the entire time. Vertically, it starts out going fast, but over time it slows down until the very top. That equals 0. And then it speeds back up. Gentlemen, Adam, Bryce. The resultant, the overall, would be the resultant. Look at that. Okay. Next question. Tell your neighbor. Correct answer is B. Okay, check this out. This is identical in terms of vertical scenario. I'm going to drop this one. I'm going to throw this one. I'm going to throw this one up. Which one's going to hit the ground first? If that was an obvious answer, this is the exact same thing, just in the vertical direction. Okay? Now, what is the difference between what I just did here and what we did demonstrating yesterday. How is that different? Like that hit at the same time. Right. This one was thrown horizontally. This one was thrown at an angle. Like in the question here, it's thrown up. This one yesterday was just thrown out. So your initial vertical velocity was 0. Here you had an initial vertical velocity. Was not 0. See the difference? Okay. All right. Here we go. There's a number 6 on the worksheet, just with different numbers. All right. 30 meters a second at 20 degrees. I want you to draw 2 diagrams. The first diagram is your initial velocity vector. Okay? The second diagram is I want you to draw the path taken. Okay? I want 2 different diagrams. I found this is a very helpful suggestion. This diagram, we are designated that for meters per second. This diagram, we're designating that for meters. You don't want to mix the two. Okay? So here's my initial, here's my final. I want to know how long it's in the air. Okay? Then I'm going to set up my chart. Horizontal and vertical chart. Which side does 30 meters per second go into? The horizontal or the vertical?
Vertical.
Is this going purely horizontal? Purely vertical? Does not go in either one. Okay? Okay, so what do we do if you're given a vector at an angle? Do trig, do your components, okay? So, I want your initial horizontal velocity, and I want your initial vertical velocity. Go, calculate it.
It's 2 points.
Okay, tell me, what was your initial horizontal velocity?
VIX was 28.2 and VIY was 10.3. Meters per second.
Okay? Now, can I stick this in the chart? Red and the green. Yes. Okay? Now, does everybody see where that came from? Okay? Never stick a vector at an angle into a kinematic equation. That is automatic death. Okay? You must break it up into components. Okay? Don't ever take this and like stick it in a kinematic equation. Ugh. Okay? Now, what's my final horizontal velocity?
0. Oh, 28.2.
Continues to be 28.2. I am fine if you write it like this. Your horizontal velocity is 28.2 meters per second. Totally fine with that. Because it maintains that 28.2 meters per second the entire time. So you can, if you want to make initial and final, that's great. Horizontal acceleration is? 0. Okay? In the vertical direction, what do I know?
Final velocity.
Is what?
Negative 10.3.
Okay, before I do that, I'm gonna write what we know. So acceleration is negative 9.8 meters per second squared. Okay? I'm gonna be looking for my time. I need one more piece of information. In the vertical side, you have options, but they all correspond or relate to the fun facts of free fall. Okay? One option, this is my favorite, I heard it. How fast are you going at the end? Negative 10.3 meters per second. Velocity up equals the velocity down. That's personally my favorite. You don't have to do that. You could do vertical displacement is equal to what?
0.
Initial final, 0. Or this one, in my opinion, the most dangerous and the most like easily to fall into a mistake is to say that your velocity at the top is equal to 0. But then to get your time, what do you need to do? You need to double your time. That one's like, you can do it, just know that that's a thing, okay? So, here's my, so I'm gonna plug that into a kinematic equation. Okay, question. Do the 10.3s cancel out? No. When you bring that over, this becomes a negative. So negative 20.6. 9.8. Your delta t is close to 2. 2.1. Okay? Good with that? Questions there? You see similarities what we've been doing? Okay? Follow-up question is what is the range? Okay, if it asks for the range, that is delta x. Think of a golf range. How far did it go? Okay? In the horizontal direction, you know velocity is constant. So you can use that. You could use a kinematic equation, it's totally fine. Personally, this is like the most efficient way. And you find that to be somewhere around 60. Okay? The worksheet is due on Monday. You know how to do it all. If you don't want homework over the weekend, you can do it tonight. Okay? We're gonna do a lab tomorrow. Okay? So you know it all. Nope, this one will be inside. It's a fun one though.
It's a fun one.
Yep.
The egg one was fun.